Hello everyone. In this video, we are going to learn about ODE, that is ordinary differential equation, order of a differential equation, degree of a differential equation, what do we mean by linear differential equation, and its solution. Okay, so let's get started. An equation relating an unknown function to its derivative is a differential equation. As simple as that. For the first example, dy dx equals y. Y is the unknown function and dy dx is the derivative with respect to x. That means y is an unknown function of x. Second example, d2f dx square, second order derivative, plus 2xf equals e to the power x. That means your unknown function is f. Third equation, del to u del x square plus del to u del y square, and this is a spatial equation. It is also a differential equation. Now differential equations are of two types. One, ordinary differential equation, and second one is the partial differential equation. Ordinary differential equation means a differential equation which involves only ordinary derivatives, and a partial differential equation involves only partial derivatives. Okay, so the first equation dy dx equals to y, this is an ODE. The second one is also the ordinary differential equation. Third one is partial differential equation, PDE, because partial derivatives involved in this equation. Fourth one is ODE, ordinary differential equation. Fifth one is ODE, ordinary differential equation. And sixth one also ordinary differential equation. Okay, so now discuss about order of a differential equation. What do we mean by order of a differential equation? And it is very important. Order of a differential equation is nothing but the order of the highest order derivative. So for the first example, dy dx equals to y, here the derivative is dy dx, whose order is 1. Therefore, the order of this equation is 1. The second one, d2f dx square, this is the highest order derivative and its order is 2. Therefore, the order of this equation, differential equation, is 2. Third one, it's a partial differential equation, and here del to u del x square and del to u del y square, both are of order 2. So its order is 2. For the fourth one, u triple prime, that means third order derivative of u involved in this example. So a order of this equation is 3. Yeah. The fifth one, here d2y dx square in present here. So the highest order derivative is d2y dx square. Therefore, the order of this equation is, yeah, you are right, 2. For the sixth equation, here the highest order derivative is d2y dx square. That means the order is 2 again. Okay. Now come to the degree of a differential equation. So degree of a differential equation is the degree of the highest order derivative which occurs in it after the differential equation has been made free from radicals and fractions as far as the derivative concerns. For the first example, dy dx, degree is 1 because degree of the first order derivative is 1 here. 1. For the second equation, it is 2. No, sorry, it is again 1, because the highest order derivative is del 2f del x square, and whose power is 1. Yeah, so degree is 1. For the third example, here both are second order partial derivative and whose power is 1. So the degree of this equation is 1. For fourth equation, here on again the highest order derivative is u triple prime and whose power is 1. So degree is 1. For the fifth equation, the highest order derivative is d2y dx square and whose power is what? 1 again. So degree is 1. For the sixth equation, we have to rationalize this. So square it both sides. That means k square times del 2y del x square whole square, which is equals 1 plus dy dx square whole to the power 3. Note that order and degree are natural numbers. It cannot be a fractions. So here the degree of this equation 6 is 2. Now come to the point, a linear differential equation. What do we mean by a linear differential equation? A linear differential equation is a differential equation that is defined by a linear polynomial in unknown function and its derivatives. Roughly speaking, the unknown function and its derivative occurs in first degree only, and no product of them occurs. Okay. So the first equation, dy dx equals to y. This equation is linear. Second equation, again it is linear. Third equation, okay, it is linear. Fourth is not linear because u prime whose power is 5. So this is not linear. A equation which is not linear called nonlinear equation. That means equation 4 is nonlinear equation. Okay. Now equation 5. This is again nonlinear equation because argument of sine function is y. That means it is not a polynomial in y and its derivatives. Okay, so the sixth equation again, it is not linear, nonlinear equation because dy dx whose power is 2. Now we are going to learn about a solution or integral of a differential equation. What do we mean by a solution or integral of a differential equation? This is nothing but a function that is defined and differentiable sufficiently so that when the function and its derivatives are substituted in the equation, the resulting expression is an identity only. Okay, so dy dx equals to y. It is our first example. Now y of x equals e to the power x is a solution of this. Why? Because dy dx equals again the derivative of e to the power x is e to the power x, and that is e to the power x is our y. So we can write dy dx equals y. That means if we put the y value and dy derivative value in the given equation, it is nothing but e to the power x, and on the right hand side e to the power x. That means it is an identity. Okay, And the third example was del 2u del x square plus del 2u del y square. That means u is the unknown function of x and y. Often x and y are called independent variable and u is called dependent variable. Okay. Now, if we take uxy equals to e to the power x sin y, then now calculate del u del x. Del u del x. So we are differentiating with respect to x only. That means a function of y remains constant. That means derivative of e to the power x is e to the power x and sin y. Or if we calculate del 2u del x square, similarly we get e to the power x sin y. Okay, let's calculate del u del y square. Del u del y. First calculate del u del y. So e to the power x remains same and derivative of sin y is cosine y. Or del 2u del y square is nothing but e to the power x and derivative of cosine is negative of sin y. Sin y. Now put this value into the given equation. That means if we add del 2u del x square plus del 2u del y square, we will get 0, the given equation. That means it is an identity. So y of x equals e to the power x is a solution of the first equation, and u of xy equals e to the power x sine of y is the solution of the third equation. Note that a solution does not involve the derivatives.